In this video, we will solve a problem on exchange economy. This question was asked by a brother Sajid Khan on Telegram channel of Economics. Okay, let me give a brief disclaimer about this video. I will try to solve this question. The answer may be correct, or it may not be the correct. Okay, so please watch it at your own discretion. So the question is, consider a pure exchange economy with two goods X and Y. We have two goods X and Y. Ravi and Suraj are the two individuals with utility function of Ravi is being given as beta log of X times Y. Okay, and utility of Suraj is being given us as X upon Y raised power alpha respectively. The endowments are XR and YR for Ravi. That means units of good X possessed by Ravi and units of good Y possessed by Ravi. Okay, and similarly XS and YS for Suraj. That means units of good X possessed by Suraj and units of good Y possessed by Suraj. Okay, such that XR plus XS is equal to A. That means total supply of good X or total units of good uh, X possessed by Ravi and Sham is equal to A, and total supply or total units of good in this economy are held by Ravi and Sham, you know the good Y is equal to B. Okay, then their contract curve is, the options are being given here. Okay, so let's try to solve this. Now what we are being given, we are being given the utility function of Ravi. So we need to find the contract curve. Okay, so by contract curve, what we mean, it is the set of points where the indifference curve of the two individuals are tangent to each other. Okay, so on the Edgeworth box it will look like this. Let us say, okay, let us say this is for Ravi and Sham. Let us say this is like this. Okay, so the contract curve is simply a set of points, okay, where the indifference curves of two individuals are tangent to each other. Okay, so we need to derive that very indifferent contract curve here. The condition is simple, that we are supposed to find a condition. That means when the indifference curves of two individuals are tangent, the condition is simply when the marginal rate of substitution for the utility function of Ravi is equal to marginal rate of substitution for Suraj. Okay, when the slope of indifference curve for Ravi's utility function is exactly equal to the slope of the indifference curve for the utility function of Suraj. Okay, this condition we need to set out here. Now what we are being given here, we are being given the utility function of Ravi as utility function of Ravi is being given as beta log, in place of X and Y, let me write it like this, uh, X R, okay, and Y R. Okay, that means utility function for Ravi is a function of two goods, that is X and Y. Okay, R denotes the units of good consumed by Ravi here. And what is the utility function of Suraj? Utility function of Suraj is being given us as let us write in place of X. Okay, XS upon YS raised power alpha. Okay, these are the utility functions of two individuals. Also we are being told that and let me write it here, uh, units of units of good X held by Ravi plus units of good X held by Suraj is equal to A. Okay, it can be any number, and units of set category units, we are being given units of good Y held by Ravi plus units of good Y held by Suraj is equal to B. These are being given us here. As I have told you, we need to set out this relation, marginal rate of substitution of utility function of Ravi, and let's write it here. So MRS, okay, marginal rate of substitution for Ravi should be equal to, so what is marginal rate of, if this is our utility function, the marginal rate of substitution is simply equal to marginal utility of good X for Ravi upon marginal utility of good Y. Okay, this is the formula for MRS. Okay, marginal rate of substitution is simply the ratio of marginal utility of good X upon marginal utility of good Y. So marginal utility of good X here, if I take, that means we need to take the partial derivative of this function with respect to X first. Okay, so if u is equal to, let me write it here, I can rewrite this equation in this fashion, that is if I write beta log xr plus beta log yr. Okay, simple law of logarithms is, if log a b can be written as log a plus log b. Okay, just I am using this relation here. I need to find out the marginal utility of good X. That means I take the partial derivative of this utility function of Ravi with respect to good X for Ravi. So we have beta derivative of X will be equal to, the derivative of log X will be equal to 1 upon X, 1 upon XR. Since we are taking partial derivative, since no X is involved here, its derivative will be 0. So we will be left with beta upon XR. Okay, that means here we will get beta upon XR, beta upon XR divided by. Now marginal utility of Y means taking the partial derivative of this function with respect to Y. Okay, that means we need to take with respect to Y this time. Here, since no Y is involved in the first term, its derivative will be equal to 0. Derivative of Y will be 1. So sorry, derivative of log Y will be 1 upon Y. So we will be left with beta into 1 upon YR, which is equal to beta upon YR. Okay, that means marginal utility of good Y came out to be beta upon YR. Okay, here you can see, if I write it in this fashion, okay, beta upon XR. So we have beta upon XR. If I reciprocate and multiply it to the numerator, it will get reciprocated, sorry, YR upon beta. So beta gets cancelled, we are left with YR upon XR. So this is the marginal rate of substitution for Ravi. By the same logic, we need to find out the MRS for Sham. Okay, let's calculate the MRS for Sham. So MRS for Sham, sorry, it is Suraj, I'm talking about this Sham here. So MRS of for Sham will be equal to marginal utility of good X for Sham upon marginal utility of good Y for Sham. Sorry, Sham and Suraj, I am getting same here, in my imagination. So you can forgive for the very mistake. This is our utility function. First, let me write it here. U is equal to, we have x s to the power alpha upon y s to the power alpha. So I can write it in this fashion: x alpha. If I transpose it to the numerator, it will become y raised power minus alpha. Okay, so we have written this utility function in this fashion. So u is equal to this. Now we need to take the partial derivative of this function with respect to x first. That means du upon del u upon del x s will be equal to, so x raised power alpha, alpha will remain here. We have x to the power alpha minus 1. Okay, y raised power minus alpha. Now take, so in place of this, so we got here alpha x to the power alpha minus 1, alpha minus 1. Okay, this is for Suraj times y to the power minus alpha. This is the marginal utility for Sham for good x. Now we need to calculate for good y also. Okay, that means del u upon del y for s will be equal to, taking partial derivative with respect to y this time. So here we have y by power function rule, it will become minus alpha x to the power alpha, then we have y minus alpha minus 1. Okay, simple thing. We have y to the power minus alpha. Okay, it is derivative is simply by power function rule. This alpha becomes coefficient. We have y, then the exponent is subtracted by 1. That is what I got here, this and this y to the power minus alpha raised power minus 1. Okay, so in place of this I can write minus alpha x to the power alpha s y to the power minus alpha minus 1 s. If I solve it here, and let me write it here in this fashion, so alpha alpha will get cancelled. We have x raised power alpha minus 1 here, so I can write it in this fashion: x raised power alpha x raised power minus 1. Okay, and we have y raised power minus alpha. Okay, I'm now writing here subscripts for the sake of simplicity. So we have here x to the power alpha, y to the power minus alpha, y to the power minus 1. Let us see, x alpha cancelled, y alpha gets cancelled. So we are left with x to the power. If I transpose this x to the power minus 1 to numerator and y to the power minus 1, sorry, this x to the power minus alpha to denominator and this y to the power alpha to numerator, its exponent sign will get changed. So we will get y upon x. Okay, simple thing. So we will get y subscript s for Suraj. Okay, upon x subscript s. This is the marginal rate of substitution for Suraj. As I have told you, to find the contract curve, we equate the marginal rate of MRS of Ravi with MRS of Suraj. MRS of Ravi is equal to y subscript r upon x subscript r should be equal to marginal rate of substitution for Suraj came out to be y subscript s x subscript s. Okay, let us, and it's obviously negative here because we are left with minus sign here. Let's write it here, this minus sign. Now let's cross multiply. Okay, so we will get y subscript r times x subscript r is equal to y subscript s, but minus y subscript s times x subscript r. Okay, we are being also told total units of good x are being given here. Okay, and let me write it here. Since xr plus xs is equal to a, let us solve this for xs. Okay, so xs will be equal to here, transposing this here, it will get subtracted, it will become a minus xr. Okay, I'm solving this for xs. I need to yes, xs, whether xr upon this is yr upon xs. Okay, sorry. So we got the units of good x hold by Suraj is equal to this. Also we are being told yr plus ys is equal to b. Let us solve it for ys here. So we will get ys is equal to b minus yr. Okay, now we need to plug the value of xs and ys in this here and here. Okay, so we have yr xs came out to be a minus xr is equal to, so we have minus ys is equal to b minus yr. Okay, times xr. Okay, so we have yr ayr, okay, multiplying this minus yr xr is equal to minus b xr, minus into minus is plus, we will get yr xr is equal to 0. Okay, sorry, it is not equal to 0, we have the equality sign here. Now we can write it in this fashion: a yr, transposing this here, it will become plus b xr minus, we have yr xr, transposing this here, it will get subtracted, yr xr is equal to 0. And we can write it lastly as a yr plus b xr. Since these are the same terms, we can add them, so this will become twice yr, this is here r, okay, xr. This is our contract curve. Okay, this denotes our contract curve. And let us see if any option resembles here: ayr plus bxr minus 2yrxr, it should be equal to 0. Okay, so I hope I make myself clear. I have told you, I just I gave it a try. I'm not sure whether the method is correct, but that's it. Okay, I hope I make myself clear in this video. Thank you.